Everybody for coming to EPSEC Australia. We are going to get started. We're very lucky today to have Edwin Kwan, EPSEC lead at Tyro and other places.
Mainly Tyro.
Sorry?
Mainly Tyro.
Other titles is what I was trying to say.
So head up application security and security advisory.
Security advisory. Well-known international speaker. He's spoken all over the world, including RSA.
No pressure
He
there.
is probably the guy in Australia to hear about this subject. He's been talking about it for years. And right now, today, we're lucky. 5 steps for securing your software supply chain. Edwin, to you, thank you.
Thank you. Thanks, guys. Did I just yeah. This is wonderful. All right, guys, thank you so much for having me today. So I'm here to talk about the 5 steps for securing your software application. But I want to start a little bit about where I'm from and what I do. So I work for a company called Tyro Payments. And have you guys all heard of the company before? There's the terminals where you tap on the side, or just last week, we have the pay on your phone, right? The BYOD stuff. So the journey begins, and you see how it's relevant. So Tyro was founded in 2003 by 3 network engineers. So they had this startup in the network engineering space. They got bought over by Cisco, went to the US, did really well. This was the 2000s, the dot-com crashed. They've already cashed out. We're back in Australia, figuring out what to do next. And at that time, the RBA felt that there wasn't enough competition in the payment acquiring space. So they had a call for competition. They said, hey, we're going to offer a temporary ADI license for anyone who want to operate in this space. So those guys, I think in their early 30s, I'm not sure, were wanting to retire, but they saw this and they go, hey, how hard can this be? What's payments? It's just moving money around. It's just like switching, right? Instead of packets, you move money around. So they started a company, and the company was first called Money Switch. People didn't like that because they felt it was money laundering. So we changed the name to Tyro. After that, it took a while, and because they were network engineers, they were all very focused about building everything from the ground up. So they built the whole acquiring backend themselves. Obviously, they built the company up. And it was 2005 when they did their very first transactions. So that's kind of where, again, I should have moved my slide there. So this is how the terminals look like, if you're not familiar with that. So 10 years down the road, 2015, thereabouts, 2014, almost 2015, the RBA came to Tyro and said, hey, this temporary or restricted ADI license is about to expire. We're very glad that you took on this opportunity to get into the payment space, but there weren't that many disruptors or competitors in this space. So we're not going to renew your license once it expires. You've got 2 options. You could, I guess, work off a license from another one of the banks who have the full ADI license, or you could become a bank yourself. And those network engineers are like, oh, what does it take to become a bank? And they're like, well, you need to do 2 things. You need to hold deposits, and you need to do loans in there, offer loans and pay interest and all. And they're like, oh, that's easy. We'll become a bank. So they had a few short years to try and work towards that banking license in there. And that's when the AppSec journey started. Because before, when we had just terminals where we own the hardware, we own everything in there, our attack surface area as a merchant acquirer was very limited. We had a lot lower risk. We didn't have to focus too much on those particular areas in there. But to become a full merchant bank, we need to do all those things in there. I'm trying to move that away. And there was higher risk. You see there's apps in there. People need a way to move their money around. We needed to uplift our application security profile in there. Let me just see what's the next slide. Okay, so I'll go back one. So that's where I came in. I was up to kind of uplift security or application security at Tyro. We had to obviously meet up our 234 obligations. Those who work in the bank are very familiar with this. So we obviously did benchmark assessments and we figure out where we needed to do or what we needed to uplift. So I was here to focus on the application security space. And we spent a lot of time in a few things. We spent a lot of time in developer awareness and writing secure code. We spent a lot of time in making sure that we build things well, build things correctly, securely. So we actually did an architecture assessment of all the things that we have to make sure it was written securely. We pen tested everything. We kind of put in, different, what do you call that, security principles in place for best practices. And we did all that. And then it made me realize, wait a minute, we're doing all that. But we've got this whole other section in there that we haven't really focused on, which is the open source components in there. And open source was like an unknown for us. We didn't know those developers in there. Have they done the same training as the guys that were training to write our code? We wasn't sure what was the processes that they've done in terms of due diligence or code reviews or making sure that the code that we are using from them is secure. So we were very focused initially on writing good code, but we're like, hey, there's this whole other area here that we also need to address, which is also quite a big area. And the more we look at it, which is the software supply chain. So the more we looked at that, the more we realized that, hey, we actually have a lot of code that is actually not written by us. There's actually open source components in there. And it didn't used to be that way, right? We used to write everything from the ground up, but now we've got libraries that we leverage to build a lot quicker. And it's almost like the construction industry where houses used to be built brick by brick. It was time consuming, it was expensive. And then we moved on to using prefabricated parts. This was quicker, it was built offsite, you bring it in and you just install it. And that's kind of similar to what it felt like for our software development. We weren't building things from the ground up. We were using these libraries from the internet, putting them in together, and we were kind of just assembling our code in there. So that's when we started this journey in terms of what do we need to do. There was this report that said that 85% of our applications are actually open source components. 85%. So we spent a lot of time on securing that 15% that we were writing. But what about the 85% in there? So that was the gap that we came to the realization and we worked on to try and address that. Now, when I saw this, I actually didn't believe it. I was like, there's no way that was that much. So we did a comparison or analysis on our own apps. So we looked at this. This was a Java Maven application, and it had 12 components in there. So these were submodules or other components that you pull in from internal libraries. Guess how many open source components do you think it uses? The white space gives you a guess in there. 200? Any more? $268 out of 12. So that was just how many that we're using in there. Back a slide. Okay. $268. So the report says 85%. We found 98%. And we go, wait a minute, this is not the right thing. We're just doing by numbers, right? So let's look by size. What would the size be? Because that's the more important bit. And size-wise, we got to that. We didn't do lines after that. Sorry.
Do you account for what part of the percentage of the code is actually distributed? Because normally when you call library, you only execute a very kind of thing.
That's a very good point. So a lot of these things here are actually not being used, but we didn't have that visibility as to what are we using and what are we not using when we're bringing in. So we are finding, what we found was that if you look at the the POM file, because it's a Java application, it didn't actually have a declaration of 268 libraries in there. It did not. It had a smaller subset. A lot of this were actually transitive dependencies. And when you speak to a developer to go, do you actually use it? Do you not? They cannot tell you with enough certainty as to, is this actually an executable code path? So that's the challenge that we have up there. And this is just some stats that we saw in that report, that this is just how much open source components that were being downloaded. So 675 billion last year. And what we saw on the trend was that there is a 36% year-on-year growth. So we're using a lot more components. So we're moving in that space quite a fair bit. If you're using JavaScript, it's a lot more. And I think for those of you who are familiar with JavaScript, you actually pull in a lot more external libraries than you actually realize, or maybe you do, but you're using a lot in there. Huge growth numbers in there. We recently did a comparison just within ourselves for what are the transitive dependencies, and the rate values are actually transitive dependencies compared to the blue ones, which are our direct dependencies. So this open source thing is huge, it's massive on there. Some of the things that we saw was that 1.2 billion vulnerable dependencies are being downloaded each month. So it's widespread. Everyone's using it. A lot of these transitive dependencies are where the vulnerabilities are. So you might not be pulling something in that is vulnerable, but it might be depending on something else that has the vulnerability. So we're noticing that the problem in there too. Like Log4j is a good one, right? You might not be pulling in directly, but you're exposed to that. And 96% of known vulnerable downloads are avoidable. So this is a big area we decided, hey, we need to focus on that. So this one I just put in just this week because I'm not sure if you guys remember, last week was on a Friday, PyPy, which is the repository for Python libraries, announced that they are temporarily suspending all new users and new projects registration. And the reason is the volume of malicious users and malicious projects being created have outpaced their ability to respond in a timely fashion. So it's not just vulnerabilities from people running code that has vulnerabilities in there. It's also malicious actors putting things in there like typo squatting attempts to try and trick developers to get things into their systems. So the other one was Log4j. We all were familiar with that. Probably some of us didn't have enough sleep as a result of that. But what we saw was when it happened, which was around here, there were some fixed versions that were available. And in August last year, 35% of all downloads were still downloading the vulnerable versions. Like, why is that? Like, we all know it's vulnerable. Why are we still downloading it? Partly is because we might not have the visibility. We might not know what we're using because a lot of it's transitive dependencies that we're pulling in there, or there could be some other reasons for that. And what we're seeing, you guys probably see the news every time, right? This is being exploited, that is being exploited. We're seeing more and more attacks happening in supply chains. So huge amounts in there. This is a real problem that needs to be addressed. But it's pretty hard. What we found, what we saw is that a large percent of the open source components out there are actually inactive. They're not being maintained. They're not being supported. They're not being actively used. So it's a really hard thing to kind of determine. And an average app that we found has about 1,500 dependency changes a year. This is working on an average of 150 dependencies an app, which for the example, we overshot, but generally that's what we think average is. And you get about 10 changes per dependency coming in. So that's a lot of work for a developer. I don't know about you guys, but I know it is hard to maintain your applications at the latest versions. And as developers, you're always working to new features, new apps. And the things that you have to maintain just keeps growing and growing and growing. So you might be working on 2 apps now, but you might be doing 3 or 4 in a year's time.
Is that why I posted a couple of days in my app store? Non-stop.
That's probably why. But the app store updates for you automatically, right? do we do it for this? Yeah. And on top of that, their job is not just to update dependencies, right? Or to deal with that, they have to produce new software faster. So it is a tough problem, and everyone's frustrated. We're trying to, I guess, build quicker and be secure at the same time. And sometimes those two are in conflict. What can we do there? So that's why I come to the 5 things that I believe we all should be doing to secure our software supply chain. Let me just check how I'm going with time. Still on track. First one, we heard this a long time ago, quite a bit, the maintaining of dependencies, having a software bill of materials, an SBOM. I think 2 years ago, the White House talked about this quite a fair bit. We're seeing a lot more traction on this. The reason why we want to do this is when you do know of an incident or a vulnerability, a 0-day, you can quickly determine, hey, what is my exposure? Which applications are exposed? Are those the applications that are externally facing? Are they the ones working on our sensitive data? Are they on our critical applications? And then you can kind of work out exploitability and like how quickly should you be patching those? So software bill of materials, I think we all should have that for all our systems that we use. The next one, so I refer that to what's in your water. You know, the good analogy is when we go to the grocery store today or the supermarkets, everything has a label that tells you what's in there. Granted, a lot of it we don't understand. It's like wording in there, but it gives you visibility of what's actually in there. Like, is this pure water, or is there like magnesium sulfate, potassium chloride, salt, additional stuff in there? It would be good for you to know. So I always ask the question, you know, what's in your water? What's in your software? The next one is to perform due diligence, to scan your components for vulnerabilities. This is the one that I think everyone is aware of, right? Make sure there are no vulnerabilities in there. We have a process where when you are doing your build as part of your CI/CD pipeline, we do a scan. If we find a vulnerability, we will break your build. And the intention on that for doing that is to give you the visibility that, hey, there is a vulnerable component that you are introducing into your application. And from there, it's up to the developer to do the due diligence to determine, is it on the exploitable path? Should I be using that? The other thing that you want to be doing is to make sure you only use the highest quality component. I know we still got some ways to go with that, but some companies use pretty much every version of everything across the company, and that just makes it really hard to manage. So you want to kind of use the highest quality components. What kind of logging libraries are you using? Is it just Log4j, or do you also use Logback, or all the other ones in there? Pick ones and kind of stick to that, and automate that into your development process. And that's the approach that we took. This application security team is a small fraction compared to the development team. So we cannot do this at scale if it was a manual process. It had to be an automated process in there where it is developer self-serve, providing them the information and they can take action based on that. So performing due diligence is very important. And this is how it might look like. You get your water ingredients telling you what's in there, and it gives us a scorecard. What's good, what's not. Next, have a centralized artifact repository. So one thing that I did, so I was in the application security space for a while, and I started out in that space, and then I moved into the security advisory space. And that sounds very broad, but one of the things that I do in there is third-party due diligence on any third-party vendors that we bring in. And when I got into there, I realized that, gee, we're doing a lot of due diligence for third parties. We ask questions like, hey, can I see check the contract? What is the SLAs? How are you handling our data? Can you show us your ISO documentation, your PCI documentation, your pen test report? We do all that. But then when I look at open source software and how developers bring those in, it feels like sometimes for some organizations, it might be like the Wild West. Just pick whatever you want from anywhere in the internet, and that just works. And it feels like there's a huge disparage in the process in there, and it shouldn't be. So one way to do that is to have a centralized artifact repository where you have an approved list of things that can be used in there. So that means that developers are using software that is approved, and they're also getting it from an approved source. So they're not downloading a component, a lesson component from somewhere else. They should just be getting it from the original source. And the way you want to do this is, the way we took about that in the past was our CI/CD pipeline was configured that it could only pull in dependencies from that particular repository in there. And the approval process has to be something that is really lightweight and automated. So it's not you need to come to the security team to ask all these questions. It is based on some policies that you have in there. And one of them is there should be no vulnerability in there. The other thing that we look at is also on the age of the component. So if you're bringing a library in and this version was 10 years old, should we really be using it? Is there a newer version available? Is it still being supported? If the answer is there is no newer version available, so that's what you should have in there. So that's kind of how our system used to look, where you have an approval process, you bring it in, and on the workstation, developers can use whatever they want, but in the pipeline, it is configured to only pull from that particular source in there. So number 3, have a centralized artifact repository. Number 4, update stale dependencies in there. One of the things that we struggled with when we started off was when we had that visibility of all the vulnerabilities in our open source supply chain, it was really hard to update our systems. Partly because they were so stale, there were a few major versions behind. So security was quite a onerous task for some of the teams to kind of update all that. So one of the things that we tried to do was we tried to make sure that when we bump things up, we keep them at the latest version. Or I know some of you, this is very contentious. Some say don't use latest, use N-1, whatever it is that works best for your organization, but keep it in a path that when you do have a vulnerability, it is easy to remediate on there. So make sure you update your stale dependencies. This was a screenshot from what we tried to do, I think a while back when we used Dependabot, or before Dependabot was part of GitHub. So we automated all that. There were some learnings that I had from this. One was this automated approach works really well if your libraries are already up to date. When we automate it for things that are really far behind, it causes a lot of frustrations because we're breaking builds. And this works really well if you have really good automated test coverage. So for some of our older systems where there was a manual testing process involved, like you need a terminal to actually test it, that kind of stuff, that didn't do too well because it would go green on the build, but it would fail to start up, or it would have problems starting up. So that was some of the things that we learned from that. And I'm on to my last one. Oh no, so sorry, keep going on this. So these are the 8 rules that we talk about when we're upgrading to the optimal version. So when we look at what should we upgrade for, don't choose an alpha, beta, release candidate version. Pick one that is officially released. Don't upgrade to a vulnerable version. So that's one thing that we ask everybody. Upgrade to a lower risk severity if your current version is vulnerable. So there's no good version available. Pick the one that's least bad in there. And when a component is published twice and close the session, choose the later version, please. And then how to avoid bad choices. Choose a migration path others have taken. So don't pick something that no one's upgraded to that path. Pick something that is more common, because chances are it is a backwards compatible upgrade. And that ties in with choosing a version that minimizes breaking code changes. Picking one that's popular. I've always been saying pick popular ones because they get a bit more scrutiny. And when they get more scrutiny, people find issues in them, and there's a higher chance that they get addressed when there are issues. And if all else is tight, pick the newest one. So that's just some of the 8 rules that we talk about for upgrading the versions. And the last one. So we realized that we can do all these things in there to try and reduce the risk or the likelihood of vulnerabilities getting in there. But vulnerabilities can and do happen. You might not be aware of. So then how do you respond to this? You don't want to be determining how you respond to this when it actually happens. So you need to have a playbook in there. How do you determine the exposure? And we talk about the SBOM. So that's what we look at straight away when the Log4j came along. We straight away went, hey, what are our exposure? We look through that, kind of go, these are the apps that are exposed. These are the owners that are in there. Let's go and talk to them about that. Block the access. If you have a centralized repository, blacklist it so that people don't introduce them into their code now. So we stop access from that straight away. And then determine how you want to address the vulnerability in production. Is it an easy fix? If it's not, what do you do? Do you put some sort of compensating controls or some sort of mitigation in there in your web rules, buy more time for your developers? How do you prioritize this among everything else? You need to work that out. And you need to work that out before you have a vulnerability that needs to be addressed straight away. What do they call it? An extreme vulnerability, right? Before you get one of those. So in summary, these are the 5 steps for what you should be doing. So maintain a software bill of materials, an SBOM, perform due diligence, make sure you don't introduce any vulnerabilities into your application, block it earlier, have a centralized artifact repository so that you only use approved components, update your stale dependencies, and make sure you have a vulnerability response playbook. And with that, I finished my presentation. Thanks, guys.
I find often when I'm using like a JavaScript framework, it will depend on an outdated version. That's like majorly outdated. So a great example is a lot of front-end frameworks depend on Core.js, and all of them depend on Core.js 2.0 for some reason. And it says very clearly, everyone that uses Core.js, this is deprecated, don't use this, it's broken, it's bad, it sucks. And like, there is nothing you can do about it. All the, like, they all depend on it. Like, so what do you do in a situation like that? Would you rather be more annoying to developers and say, hey, you need to find a solution around this, or would you rather not annoy developers so much and try and find some sort of solution?
Yeah, that's an interesting one. I can tell you what not to do. Don't fork the project yourself internally and then try and fix that in there. Or you contribute back and try. What we have done in the past is when these things happen, and they do happen, right? So that's one good example in there. We then look at what is the vulnerability, what is the exploit itself. So we've gone to the point now where initially we say we have 0 tolerance for vulnerabilities. Everything must be fixed. We've come to the realization that it is hard to keep up with that. You talk about exploitability. We also look at that so what happens is when there's a vulnerability, the first question we ask is it an easy fix? Is it just a bump in there? And if the answer is no, in that case, then the next question is there something we can replace them with easily? If the answer is no, then we're gonna go, what is the risk or the vulnerability in there? What's it specifically? How are we using it in that way? Some of the things that we have looked at is, all right, it only gets called when you use the library in a certain way. And we did that once, and we wrote some unit tests to fail when we detect that people are using the library in a particular way, and say that as long as those are good, you're okay to keep using this. Or we look at other compensating controls.
Direct, it's really hard to trace that dependency on the defense, which is like the example in this case. And sometimes it's not a specific vulnerability. Like, I don't know if it's a specific vulnerability because no one's looking at it.
Yeah.
I'm sure there are vulnerabilities that no one's looking at.
But you have the description of what the vulnerability is.
But what I'm saying is version 2.0 of this is not maintained by the developers anymore. So there might not be a specific vulnerability, but no one's looked at it for years.
It's outdated.
Undoubtedly.
Yeah. That's a good one in there. I think it's on a case-by-case basis. We haven't dealt with that one specifically, but we've dealt with ones where we did the unit tests. We've kind of looked at certain things on how can we reduce the likelihood of something happening.
And I just asked because it's something I ran into and I was really hoping that you didn't have like this amazing idea. but-
This is how you do it. If I find out, I'll do another talk on that. But
So we have an online question.
yeah,
Steve is asking if you had to begin implementing these recommendations now, how would you start?
so I remember when we started this journey at Tyro, we started off with understanding what are all the components that we use in there. We had this in there to prevent more things from coming in. We took the approach initially of just grandfathering everything in there, and this is all for new stuff. We do that process in. We then went for the vulnerability approach to determine what are all the CVs that we have. We actually grandfathered all that to say that those are okay. Any new ones will come in, will have this policy in effect. With the old ones, we went by a vulnerability rating risk-based approach where we went with your higher CVs, and we took the old-fashioned approach. We created JIRAs and we gave to teams and said, hey, by X days, please fix this because we're going to change the build to fail after that on those particular things. And then we worked our way down. It took a while, and I think it took us about 2 years to get to where we were happy. That was when we had a zero vulnerability policy. It was 2 years when we actually got to almost zero in that. So that was the approach that we took. Understanding what we had, restricting the new things coming in, putting the policies on for those, and then taking an approach by working with the highest ratings and going old-fashioned way with teams, with JIRA, so that they can go into their iteration or their sprint to kind of work at a sustainable cadence that doesn't impact their feature delivery too much. That help? Yes.
There's a lot of mention of failing builds, failing pipelines. In your experience, is that the only way to get developers to care about solving vulnerabilities?
It was an approach that we took. It wasn't very popular when we did it. It was, so we tried the education piece that had some positive outcomes from that. But when it came down to delivery timeframes to say, hey, we want to get this in by Friday, tomorrow, all those goodwill and approaches kind of fall out the door and say, hey, we'll fix that later. And later never comes along because the next feature comes in. So that was an approach that we put in there as a hard rule, almost to kind of push that back to delivery and say that was a delivery, what is that called? Non-negotiable, that you have to be that before you go out the door. So we had a lot of pushbacks initially. It wasn't a very popular decision. But when we did get to it, I think people appreciated it from there.
Yeah, awesome.
Any other questions?
I have a question. One of my mates works at Tyro, and he was saying that some of your workloads are on like Kubernetes, like containers. Like, how are you thinking of things like code signing or signing like your container images and things like that? Just because I know using like random Docker images, this gets even harder.
Yeah, we've been talking about that a little bit. Or was it you who asked me in terms of what we're looking at next?
Yeah, just in general.
I think that is an area that we are getting a bit more focus in. There's a few approaches that we've considered that we haven't really tried yet. I know we talk about focusing more on the golden images and some of those processes. So nothing specific because we're still experimenting in that space to see what actually works well in there. And it's always, I guess, a balance between what is a good approach, but also what's an approach that is good guardrails for developers so that they can kind of move fast in there too.
Cool, thanks.
Throughout this process, if you had to do, oops, sorry.
Everyone's getting a go.
Thanks,
All right.
Greg. Throughout this process, if you had to do something differently again, would there be something?
If I had to do something differently, what would I have done to try and roll this out? Good question, actually. I think I would. We took 2 years to get that initial jump, and that was when we got our banking license, actually. So it coincided really well. And I want to add that we had buy-in from the top because we wanted to get that license, and we tied that license to security, and we tied that to that. So that was a lot of executive board buy-in to push that in. If I were to do that again, I would have taken the approach a lot quicker with the breaking the builds. What we found was that we had what we call an SLO, a service level objectives, that says, hey, when you have a vulnerability, I told you that we first break the build as an awareness thing, but then teams can go and take a few options. The options are, hey, this is not applicable. We ask, why don't you just remove it? Sometimes it's hard. Or they can say that, hey, I need a bit more time because I'm actually doing a patch right now for something that's broken in production. I can't be doing this. So we have that process. And when you do that, it kicks off this SLO process where based on your risk, you got how much time to fix it. And we had 2 weeks for a high. So yes, if it's a critical, which is a 10, it's a drop twos, get on it straight away, no exceptions. If it was a high, it was 2 weeks, which is one sprint, one iteration. So if you're not scheduled for this, do it the next one. So it's 4 weeks, because then you have exactly another iteration to work on that. If it was a medium, it was 3 months. If it was low, it was 6 months. And I took that approach going, they needed more time to fix things. But if I were to do it again, I would reduce that time considerably, because what we found was that people just ignored it until it passed the date, and then it broke, and then they fixed it anyway. So that would have been the approach I would have taken. Maybe it would have been not very popular too. It probably would not be popular, but it would have been quicker.
Thanks.
Ooh, if that's it. Thank you so much, guys. Really appreciate you guys coming to this, and thank you for the opportunity to have me here.
Yeah, Edwin. I'm gonna end the online recording, and I think we can stand up and socialize, maybe have a drink, and maybe pizza. Thanks for coming, everybody.